Okay, in this video, we're going to solve this problem right here, and so let's begin. Now, obviously, if this was the integral of x, this would be a very easy problem to solve. But because it's an absolute value of x, we need to think about this. So the absolute value of x behaves a certain way. It behaves like an ordinary x whenever x is greater than or equal to 0. Let's think about it. If x is 0, 0 is 0. 0 is 0. If x is 1, 1 is 1, 1 is 1. Now, it behaves like negative x whenever x is less than 0. So for example, if I put a negative 1 here, negative 1 is positive 1. If I put a negative 1 here, absolute value of negative 1 is still positive 1. Now, we're bounded from negative 3 to 5, and we see if x is less than 0, it behaves this way. And if x is greater than or equal to 0, it behaves this way. So I'm going to split up this integral. I'm going to say I have negative 3 to 0 for negative x dx, plus I'm going to say from 0 to 5 it behaves like x for dx. So the integral of negative x is going to give us negative x squared divided by 2, and we're bounded from negative 3 to 0, plus x would give us x squared divided by 2 for 0 and 5. And now we just need to swap. If I plug in a 0 here, 0 squared still going to give us a 0, minus I plug in a negative 3 here, negative 3 times negative 3 is positive 9, but you have a negative here also, so it's a negative 9 divided by 2. So we'll put negative 9 divided by 2. Then we'll do this piece. So plus, I put a 5, 5 squared is 25, so I have 25 divided by 2. Then I put minus, I put in a 0, which is still going to give us 0. So minus minus is positive, so we have 9 divided by 2 plus 25 divided by 2, and that's going to equal 25 plus 9 is 34, so 34 divided by 2 is equal to 17, and this right here is our final answer. And using a calculator, we can also confirm. And that's pretty much it for this video.